Hello friends, I am Sonam and welcome back to my channel. Today we talk about the one of the most curious topic among the physicists and for the science lover. Today we are talk about the dark matter, so let's get started. Universe is expanded over the large space and it hides the many mystery and we don't know about it. Among them one is the dark matter. Still we are thinking that matter in the universe are in the form of planet, star, asteroid, comets, animal, tree and many more, which we can see without any difficulty. But actually this is not. In real we can see only the 5% of the matter in the universe. In simple, dark matter is composed of the particles that do not absorb, reflect or emit light, so they cannot be deflected by observing the electromagnetic radiation. We know that dark matter exists because of the effect it has on objects that we can observe directly. Dark matter is the most mysterious, non-interacting substance. Its gravitational effects are necessary to explain the rotation of the galaxies, the motion of the cluster, and the largest scale structure in the entire universe. The visible universe, including the Earth, the Sun, other stars, and the galaxies, is made of the photon, neutron, and the electron bonded together into the atoms. Perhaps one of the most surprising discoveries of the 20th century was that this ordinary or the bionic matter makes of the less than 5% of the mass of the universe. The rest of the universe appears to be made of a mysterious invisible substance called the dark matter, which contains 25% of the matter and a force that repels gravity known as dark energy, which is about 70%. Dark matter has been given this name because it does not seem to be interact with the regular matter in any way. It does not collide with it or absorb energy from it. We cannot see it or detect it with any of our instruments. We only know it's there because we can see the effect of its gravity. Dark matter was first theorized in the 1930s by the Wiki to account for the movement of the galaxy cluster, but the modern calculations were made by the Vera Rubin in the 1960s and 70s. She calculated that galaxies were spinning more quickly than they should, so quickly that they should tear themselves apart like a merry-go-round ejecting children. Rubin imagined that every galaxy was stuck inside a vast hollow of the dark matter that supplied the galaxy to hold the galaxy together. But there was no way to actually detect this stuff, so astronomers proposed the other model. But in the last few years, astronomers have gotten better and better at detecting the dark matter purely through the effect of its gravity on the path that light takes as it crosses the universe. As light travels through the region of the dark matter, its path gets distorted by the gravity. Instead of taking a straight line, the light is bent back and forth depending on how much dark matter it passes through. Two theoretical physicists at the University of California, Davis, have a new candidate for the dark matter and a possible way to detect it. They presented their work June 6 at the Planck 2019 conference in the Granada, Spain, and it has been submitted for the publication. Many physicists believe that dark matter is made of some particle yet to be discovered for some time. The favorite candidate has been the weakly interacting the massive particle or a WIP, but despite years of effort, WIPs have so far not shown up in the experiments designed to detect them. We still don't know what the dark matter is. The primary candidate for a long time was the WIP, but it looked like that almost completely ruled out. An alternative to the WIP model of dark matter calls for the forms of dark electromagnetism, including the dark photons and the other particle. Dark photon would have some weak coupling with the regular photons. The physicist Paul Dirac predicted that an electron moving in a circle near a monopole would pick up a change of the phase in its wave function. Because electrons exist at the both particle and the wave in the quantum theory. The same electron could pass on either side of the monopole and is the result by slightly out of the phase on the other side. Many scientists have also pointed out that known properties of the dark matter are consequent with the cosmological constant, a mathematical band-aid that Albert Einstein added his theory of general relativity to make his equation fit with the notation of the static universe. According to the Einstein, the constant would be the repulsive force that counteracts gravity, keeping the universe from collapsing it on itself. Einstein later discarded the idea when astronomical observation revealed that the universe was expanding, calling the cosmological constant his bigger blunder. Now that we see the expansion of the universe is accelerating, aiding in the dark energy as the cosmological constant, could Hadley explain how the space-time is being stretched apart, but that explanation still leaves scientists clueless as to why the force exists in the first place. Thanks for watching. Please subscribe the channel for the more informative videos. Thank you.